So let's talk about AI and security. It's really a two-way street, isn't it? On one side, you've got the whole challenge of securing these new AI systems themselves. And on the other, we're trying to use that very same AI to actually make our security better. It's this dual challenge, this big opportunity that's really changing the game for all of us in the field. All right, so here's how we're going to break it all down. First, we'll get into the agentic AI challenge. Then we'll dig into the security gaps that are just baked into LLMs. After that, we'll talk about a potential guardrail, automated reasoning. Then we'll switch gears to see how AI is helping out security teams, and we'll wrap it all up with 3 key things you can actually go and do. Okay, first up, the big shift we're all seeing is that AI isn't just answering things anymore, it's doing things. It's moving from just responding to actively taking action. And that right there is the heart of the agentic AI challenge. And the difference here is, well, it's huge. Think about traditional automation. It's very rule-based, right? Super rigid. It needs structured data and just follows a script someone wrote. But agentic AI, it's a whole different beast. It's driven by foundation models, so it's built to handle messy, dynamic situations. It's not just following a script. It's orchestrating these really complex, multi-step workflows all on its own to get a job done. You know, that word orchestrate is really the key. These agentic systems are like conductors of an orchestra. They're pulling together the foundation models, grabbing data from different sources, and using external tools. The point is they're not just spitting out text. They're actually coordinating real action out in the world. So what does that look like in the real world? Well, it means these agents can do things like call APIs, hit databases for information, string together a whole bunch of model interactions, and even talk to other agents. And all that power, that agency, it creates a completely new threat surface. Suddenly, we have to be hyper-focused on things like identity, permissions, and the whole runtime context. Okay, so that brings us to a really fundamental problem. If we're going to secure these powerful systems, we first have to get our heads around why the LLM itself just can't be a security boundary. And the reasons for that are baked right into its architecture. First off, their behavior is just not predictable. It's non-deterministic. You can give it the exact same input twice and get 2 different outputs. That's because of things like sampling and the randomness in how it generates tokens. So how can you possibly build a reliable security control on top of something that you can't guarantee will do the same thing every time? You can't. Second problem, equal privilege processing. Inside the model, everything is just mush. It's all one flat stream of tokens. Your system prompt, the user's input, data it just pulled from a database, it's all treated exactly the same. There are no walls, no compartments. So trying to enforce access control inside the model, it's just architecturally impossible. And number 3, remember what these things are at their core. They're statistical pattern matchers. They're not doing logical deduction. They're just completing patterns they saw in the training data. And that's where hallucinations come from, right? The model spits out something that sounds totally convincing, but is just plain wrong. The bottom line is, you simply cannot trust the output without some kind of external check. So you put all that together, the non-determinism, the equal privilege, the pattern matching, and you arrive at one single, inescapable conclusion from an architectural standpoint: the model is not and cannot be a security enforcement point, period. Security has to be built around the model, not in it. Okay, so if the model's probabilistic nature is the core of the problem, what's the solution? Well, this is where we can look to something deterministic to build our guardrails. And that brings us to this idea of automated reasoning. The whole goal here is to get to provable correctness. So it really boils down to this question, doesn't it? How in the world do we enforce correctness and make sure these systems behave predictably when they are, by design, probabilistic? And one powerful answer to that is automated reasoning. A good way to think about it is like applying a mathematical proof to your software. It uses formal logic to prove mathematically that your system will always follow a specific set of rules no matter what you throw it at it. Let's put this in perspective. You know, machine learning gives you a probable prediction. Traditional testing, it just confirms things work for the specific scenarios you thought to test. But automated reasoning is different. It verifies the entire system against a formal model, and the result is a mathematical proof that it's correct for all possible scenarios. We're talking about a completely different level of assurance here. Let's make this real with a quick example. Imagine an airline refund policy. A customer chats with an LLM bot and asks for a refund, and the LLM says sure.
Now, instead of just blindly trusting that and issuing the refund, an automated reasoning guardrail kicks in. It checks the LLM's answer against a formal model of the actual policy. It verifies the facts. Was the flight really canceled by the airline? Was the reason actually operational? Only when those conditions are met, and it has proof, does it confirm the action is correct.
And you can apply this logic all over the place in security. Think about it. You can use it to verify that AI-generated code is memory safe. You can use it to validate your infrastructure configs against security policies. You can mathematically prove that your authentication and authorization logic is watertight. Or you can use it to check that some compliance statement an LLM generated is actually backed up by the facts in your knowledge base. All right, let's flip the coin now. We've talked about securing AI. Now let's talk about using AI to help out and scale our own security teams. So, where is AI actually being used in security today? Well, the efforts are kind of concentrated in a few key areas. AppSec is a big one. And right behind that, you've got threat detection, general security operations, and of course, vulnerability management. So in AppSec, what this looks like is putting AI agents right into the development workflow. They can give developers feedback in real time, right in their IDE. They can help automate parts of pen testing. And they can even suggest code fixes for vulnerabilities. The whole point is to speed up the entire secure development process. And for threat detection, AI is a huge help in automating the research into new TTPs. It can take that research and generate new detection rules. And what's really cool is it can use standardized schemas, like OCSF, to normalize all the event data coming from your different tools so you can actually analyze it all in a consistent way. And the efficiency gain here it's just off the charts. Seriously. A skilled security engineer could easily spend over an hour digging into a single CVE. But a Gen AI app that's been properly grounded with the right context, it can do that same analysis in seconds. An hour versus seconds, that's a massive shift. Okay, so this is all great, but how do you actually put it into practice? Let's wrap up with a really clear 3-step framework you can use. First, you've got to secure your own generative AI. Figure out if you're buying or building, because that defines who's responsible for what on the security side. Second, start using AI for security. Find those routine, high-volume tasks that are perfect for AI to handle, but, and this is key, keep humans in the loop for the big, critical decisions. And third, you have to protect your organization against AI threats. That means constantly watching for new attack vectors and keeping your threat models and your controls up to date. And all of this really leads us to the big question we all have to wrestle with going forward. As we bring these incredibly powerful tools into our SOCs, what is the right balance between letting the AI run and keeping a human in charge? Finding that sweet spot, that equilibrium, that's not just a nice to have. It's probably the most critical thing we need to figure out to succeed in this new era.